In this video, we are going to do the structured questions related to stoichiometry, and we are doing questions for AP chemistry. And they say a manufacturer produce calcium carbonate, which is CaCO3, by reacting calcium hydroxide with carbon dioxide, and they are saying a sample of 185 gram of calcium hydroxide reacts with excess carbon dioxide. So first of all, we need to find the mole of calcium hydroxide, and if we want to find the moles of calcium hydroxide, the formula is mass divided by molar mass. Mass is how much? That is 185, and the molar mass of calcium hydroxide, that is going to be 74.096, and the answer comes out to be 2.50 mole. Then they say the mass of calcium carbonate we need to find out. So the known is, I'm going to keep it on the left hand side, and unknown is on the right hand side. So it is going to be, the moles are 1:1 there from the equation, and if it is 2.50, then this is going to be x, and x comes out to be how much? 2.50. And then we need to find the mass of calcium carbonate. So mass is going to be 2.50. Mass is going to be mole time molar mass, mole time molar mass, and molar mass for calcium carbonate is going to be 100.09. So mole is 2.50. I'm multiplying with molar mass, which is 100.09, and the answer comes out to be 250.23 grams. Then they say in a second trial, what happens? Only 122 gram of calcium carbonate was collected, and calculate the percentage yield for the reaction. So this is going to be actual yield. Actual yield is always given in the question. Actual yield is always given in the question, and theoretical yield is this one, which we have found from the equation. So the formula of percentage yield is going to be actual yield divided by theoretical yield and times it with 100. So actual yield is going to be how much? That is going to be 122. Theoretical yield is 250.23, and times it with 100. So answer that comes out to be is 48.8%. The next part, they were saying explain the one possible reason why the yield is less than 100%. So the possible reason could be that the reaction is incomplete reaction. The possible reason would be the incomplete reaction, or maybe the side reaction consumes some of the reactant. Maybe there would be a side reaction that consumes some of the reactant. In the next question, they say a student heats magnesium metal in oxygen to form magnesium oxide. They are saying to write the chemical equation. So first of all, magnesium that reacts with oxygen, they are going to form magnesium oxide. How this becomes? Because magnesium belongs from group 2 having +2 charge, and oxygen belongs from group 6, so it is going to have -2 charge. So final formula becomes MgO, as +2 and -2 cancel out each other. So in order to balance it, I'm going to put 2 here, then it become 2 magnesium. I need to put 2 here as well. So this magnesium is going to be in solid state, this is in gaseous form, and this is in solid state as well. Now, moving towards the next question, they ask us calculate the moles of magnesium that reacts with 6 moles 6 gram of magnesium are used when 6 gram of magnesium are used. So in order to find the mole of magnesium, the formula is mass over molar mass. So mass is 6 gram and molar mass is given to us, that is 24.31, and the answer comes out to be 0.247, that is mole. Then they are saying use the balance equation to determine the moles of magnesium oxide produced. So for that purpose, I am going to put magnesium, which is the known, and magnesium oxide on the right hand side. From the equation, it is 2 mole of magnesium which are producing 2 mole of magnesium oxide. And if it is 0.247, then it is going to be X. And X here comes out to be also 0.247. They are mole of magnesium oxide. Then they say find the mass of magnesium oxide. So mass is going to be mole, which is 0.247 times with the molar mass, that is 40.31, and the answer comes out to be 9.96 grams. So in the next question, they say hydrogen gas reacts with nitrogen gas to produce ammonia, and then they say a student reacts 1.50 mole of H2 with excess N2. Identify the mole ratio of H2 to NH3. So H2 moles are 3 and NH3 moles are 2. So if they want me to find the ratio of H2 over NH3, so H2 moles are how much? That is 3 and NH3 moles are 2. So it is going to be 3:2. Then calculate the moles of ammonia produced when 1.50 mole of hydrogen are reacting. So we have H2 moles which are known. I'm going to put it on the left hand side, and unknown I'm going to put on the right hand side. So first from the equation, that is 3 moles of hydrogen that are reacting with 2 moles of ammonia, and if it is going to be 1.50 mole of H2, it is going to be X. So they would be cross multiplied, and it is going to be 3x is equal to 3, and X comes out to be 1 mole. X comes out to be 1 mole of ammonia. Now they are saying if the reaction occurs in a container at 25 degrees Celsius and 1 atm, calculate the volume of NH3 gas produced. Use the ideal gas equation. So for that purpose, I need to use the ideal gas equation and I need to calculate the volume of NH3. So PV is equal to nRT, and I need to find the volume for that. nRT divided by P. N is how much? N is the mole of ammonia, and it is 1 as we have calculated here. R is the gas constant, 0.08206, and temperature is how much? Temperature is 25 plus 273, that comes out to be 298. It is 298, and the pressure is going to be 1 atm. So the answer of volume that comes out to be 24.5 liter. So they are saying in the next part why the stoichiometric ratio used in part B is valid for gases. The reason is that the coefficient here, the coefficient that you can see here, here and here, they represent relative mole under the coefficient represents the coefficients represent relative moles under same condition. Then in this question, they are saying a chemist reacts barium chloride solution with sodium sulfate solution to produce solid barium sulfate and aqueous sodium chloride according to the balance equation below. A solution is prepared by mixing 75 milliliter of 0.250 molar barium chloride. Molar means mole per volume. Okay, volume is in liter there, and they are saying that it is reacting with 60.0 milliliter of 0.350 molar. Molar here means mole per unit volume, and volume is in liter, so we need to convert this volume also in liter. It is in milliliter. How can we convert it into liter? By dividing by 1000, so it comes out to be 0.075 liter, and it comes out to be 0.06 liter. So in order to find the mole of it, mole will be volume multiply by this mole per unit volume, that is concentration. Basically it is concentration, so the formula is going to be concentration into volume. Volume is how much? 0.075 times it with concentration, that is 0.250, and that is mole per unit volume. So when they are multiplied, so answer comes out to be 0.1875 mole of barium chloride. And for this one, we are going to do mole is equal to again volume time concentration. Volume is 0.06 times it with concentration, that is 0.350. so answer comes out to be 0.0210, that is mole of sodium sulfate. Now these both, they are available mole, and we need to find out the required moles. How can we do that? We can use either one, that is 0.1875 mole of barium chloride, and then from equation I'm going to use the table method. You know, from equation there are how many moles of barium chloride? That is 1 mole of barium chloride, and that is reacting with how many moles of sodium sulfate? That is also 1 mole of sodium sulfate. So they both will cancel, and the answer comes out to be 0.1875 mole of sodium sulfate. So you need, these are required moles, these are required moles. You can compare the required moles with the available moles of sodium sulfate. So if you see, the available moles of sodium sulfate are more, so available mole of sodium sulfate, they are greater than required mole of sodium sulfate. So what happens because of that? Sodium sulfate is in excess, that is in excess, while the other one, which is going to be barium chloride, that would be limiting, reactant. Okay, this is limiting reactant. So here barium chloride is limiting reactant. Now they are saying calculate the maximum mass of barium sulfate, and for that purpose we need to have we need to use the limiting reactant, because limiting reactant controls the amount of product. So I'm going to put barium chloride, which is the limiting reactant, on left hand side, and barium sulfate on right hand side. So first, from the equation we can see it is 1 mole and barium sulfate is also 1 mole, and available moles of barium chloride are this much, so it is going to be 0.1875. It is going to be x, and x also comes out to be 0.1875. Now what I'm going to do, I'm going to use the mass, which is equal to mole time molar mass. Mole is 0.1875 times with the molar mass of barium sulfate. So the molar mass of barium sulfate, that comes out to be 233.39, and that comes out to be how much? 4.38 grams. Then they say a student filters the barium sulfate and dries it, finding the final mass of solid to be 6.05. So percentage yield we need to use, and this is given to us 6.05, so it is going to be actual yield. So actual yield comes out to be at the top 6.05, and theoretical yield is that we have found from the equation, that is 4.38 times it with 100. So it comes out to be 138%. Now they say explain how using excess water during rinsing of solid could affect the percentage yield measurement. So what happens there? And excess water, like what happens because of the percentage yield, as you can see, that is more. So what happens? Excess water here, excess water may not have been may not have been fully removed during drying. That is why you can see that percentage yield is quite more.